Okay, ladies and gentlemen, so what we're going to do for these types of videos is, again, I'm just going to work on the end behavior, zeros, and multiplicity. So I'm going to do the end behavior a little bit quicker since we've had some practice with this. We see that the degree is even, and we see that our leading coefficient is a positive 1. So therefore, we know that this graph is going to rise left and rise right. Now we need to get into the fun part as far as finding the zeros. So to find the zeros, we need to take our f of x, our output value, and set it equal to 0. Then we're going to set our polynomial function equal to that 0. And now we need to find the values of x that are going to make this equation true. Now, since we have a quadratic, we're going to want to look into our factoring techniques. And we first determined that we cannot factor out a GCF. So we're going to want to look into factoring. Now, before we get into the factoring of saying what two numbers multiply to give us 25, what two numbers add to give us 10, I noticed that this, 25, is a perfect square. And there's a couple things that happen when we have a perfect square. One, I want to look for a perfect square trinomial. And two, I want to look for difference of two squares. Well, this is obviously not a difference of two squares, but this is a perfect square. This is a perfect square trinomial, meaning I can rewrite this as the product of x plus 5 times x plus 5. Now, when determining multiplicity, we know that x plus 5 times x plus 5 equals x plus 5 squared. And we can see that when we have a factor raised to an even power, we know that we have now an even multiplicity, which means my graph is going to rebound at that point. So anyways, for finding the zeros here, we know that we'll have 0 equals x plus 5, subtract the 5 on both sides. So we can say x equals negative 5, and that has a multiplicity, or we could just say an even multiplicity. Or a multiplicity of 2, but since it's even, we know it's going to rebound. So there you go, ladies and gentlemen. There's your answer. Thanks.